Hello everyone, welcome back to a new lecture, and in today's class we are going to see the spherical polar coordinate system, and we are going to ask the question, show me where is small r, where is theta and where is phi, and therefore we can say r here. So this is r, that is the radius of the sphere. So where is the z-axis is here, so we have to measure from means the starting point. So my white color cursor will be on the z-axis because that is the place where I am starting, and then you have to keep moving till you reach the radius. So therefore once you do that, you put a arrow here, so that angle whatever you got is the theta. So this is how you have to represent. You should not measure any angle from the y-axis. Okay, one angle will be measured from the z-axis, another angle will be measured from the x-axis. That means the angle which is measured from the z-axis, okay, that portion or that angle is known as the polar angle, and any angle that you measure from the x-axis, this angle is known as azimuthal angle. The order of the r theta phi is to be maintained, and let us now ask the question, where is phi? Now phi representation, it requires some small work is required, and that's what I am going to explain. So now what you do is you try to project. You know what is meant by projection now. Projection means assume that the sunlight is there on top of the point P. This is the point P, and that is the length of the rod that you have. So now the length of the rod is the R. That's what you have shown, and then you are going to shine light. Either you take this manually, you shine some light. Otherwise, exactly when the sun comes on top of this, you measure what is the shadow on the horizontal plane. So to do that, essentially what we have to do is, mathematically or geometrically, what we have to do is simply draw a vertical line. So if you draw a vertical line, then essentially you are going to measure the projection. So let us draw that. So if you are going to come down like this, and then you see when it is going to touch the horizontal or the blue color, you have a blue color shaded region. That region is the horizontal plane. Now this vertical line that you are drawing, it has to come and just touch the surface. Now once it touches the surface, there you have to stop. So what happened is, now you got a projection. So this is the projection point. So the P here is projected on this particular point on the horizontal surface. So projection is obtained. Then what you have to do is, you have to draw a line from the origin for measurement. Any measurement, you have to draw a line from the origin only. So therefore now let us draw the line from here to here. That's all. So we have drawn a line like this. So once you draw the line, now you can measure the angle from the x-axis. So this is the x-axis. Therefore my white color cursor is on the x-axis. So from here you measure the angle and then say that that is the angle phi. So phi has to be measured like this. So now you know what is phi. So once these three numbers are available, then what it means to say is that we are actually locating the point P. That is the meaning. If the three numbers are not given to you, you can't locate. Locating means finding. Suppose I give you three numbers, 2 meter, 10 degree, 25 meter. The third one is also an angle. So let us assume that some 20 degree. So if three numbers are available, then you can travel and then reach that particular point. That is the meaning. So R means, first of all, how do you travel? Let me tell you first of all, how do you travel? You first of all have to travel along the by the distance of R, but before that the theta has to be clear. So which means that you have to first go in a vertical direction like this, in this particular direction along the z-axis by a distance of R, because this is also radius of the sphere. If this is R, remember, if this is R, this is also R. So therefore you first go and stand here. Then afterwards you have to make a theta. So that means essentially you have to travel like this and come here. And then what happens is, but this is actually a two-dimensional board. So you will be unable to visualize one more dimension. So horizontal, how much you are going to make a movement, that is not visible here. But if you have a real ball with you, you can make this experiment. Take a ball and then see how to locate. You can only, the difficulty will be there how to come here without knowing the phi. If phi is not given, you don't know whether you have to come like this or slightly like this, or you can also come like this, or you can also come like this, So each one is a surface of the sphere. You can travel along the curved path, but you do not know how to come. So for that, the information of phi is required. So once these three numbers are available, you will be able to locate the point. Locating the point means reaching that particular point. So let us, okay, this is clear. Now we need a small calculation based on the projections. Now let us draw a parallel to this. So I have this particular line. Let me draw a parallel of this line to this. So from this particular point, you simply join these two, which is a parallel. So this line will be a parallel to this. So that is fine. Now which is the R? R is there, theta is there. So what should be this one? Once again, I'll tell you, this is R. R is this. This is R. This is theta. So what is the opposite side? So this is the opposite side. So let us write down that this expression is R sine theta. Okay. Then what about this height? So that is equal to R cos theta. I will write it little bit outside so that the sphere will be neat. So that distance will be equal to R cos. So what do you mean by this arrow here is that the distance between 2 points. So there is a point here and there is a origin here. So these 2 points, what is the length? So that length that you measure, that will be equal to R cos theta. So basically you are decomposing this into two perpendicular direction. That is clear. So what is an advantage of this is that you got the R sin theta here from here to here, because this line is a parallel to that. Same R cos theta has to be written down here. Therefore, now I will write down that the length of this particular object that you have here, this length is also equal to R sin theta. So that construction is clear. Now only little bit additional work that you have to do, how to decompose this R sin theta into two perpendicular direction. So that is what we are going to do, and that can be done if you draw the parallels to the x-axis and y. Okay. So the yellow color line that I have drawn, you can see one yellow color line which is parallel to y-axis. This yellow color line is parallel to x-axis. So which means that there is a diagonal you are able to see. So that is the diagonal. So the diagonal value is equal to r times sine theta. So that is your diagonal. Let me write down that this gives you the diagonal in this diagram. And then what will be this component and what will be that component? That's what you have to calculate. And this is what I explained initially. So now it should be easy. So what should be the value? So this length. So this length I'll show here. So this particular length will be equal to, so you have a phi there. So because you have to make use of this particular angle, and therefore it will be equal to, I'll write this. So that should be equal to, so that is the distance that you have. X will be equal to r sin, I am putting a bracket here so that r sin theta is one object, and then the component is just getting multiplied by cos theta. Now similarly, what will be this another length? So let me show this particular length that you have, which is an orange line. I think these two are orange lines that you have. The length of the orange line is what I am showing here. That will be equal to, so let me write down here. So that will be equal to, so that is, shall I write y? So that should be clear. Why I am writing y, that is important, because this is y axis. So this is y axis. This is the direction of the y axis. This is the direction. And this particular orange line is also parallel to that y. That is why I am writing y here. Now similarly, I did not explain why did I write x here. The x I am writing because this particular orange line is parallel to the x-axis. So therefore anything that you measure will be the length measured in the x direction. That is why I have written x here. So therefore now y will be equal to the same r times the sine theta multiplied by its component. The component will be a sine phi. And that's all. Now here there is another arrow. So note down that there is a arrow here. And what is the meaning of this arrow? It is the distance from this particular yellow point. So now I am making this point as an yellow. So yellow point to this particular center, on which once again I will make it as a yellow point. So the distance between the two yellow points shown here will be equal to r times cos theta, that you already calculated. But I'm asking the question whether it is x direction, y direction, or z direction, that you have to find. You see that this particular length is along the z axis, and therefore this must be z equal to r cos theta. So now, after doing this particular simple trigonometry, it's a trigonometry, and you are basically decomposing a particular length into two components. That's what you are doing, but you are doing it two times. That is the whole thing. We are doing the simple thing, but it is two times we are doing. You see here, just now we have done that one. We are considering the vertical one, vertical right angle triangle we considered and then decomposed. And once you finish that, we are taking a simple two-dimensional thing which without going in the vertical direction. Only you are staying in the one plane, and then you are doing this. So once you finish this, the same thing or whatever exercise that you have done is the same thing that we have done in the case of the sphere also. So that is why I have first itself explained the basic concept of the decomposition. It is only the decomposition. The figure may look more complicated if everything is shown at a time. Suppose if I show this particular figure directly without explaining, then it appears to be something more complicated. But if you do it step by step, okay, one by one, then all the things will be quite clear. Now, our conclusion is the following. Our conclusion is, after doing all these things, what did you achieve or what did you get? So, our conclusion I will highlight now. So, what is that we have found out is that we have found out this one, z equal to r cos theta. That is the first thing that we found out. The second thing is there is one more thing here, which is x equal to r sin theta cos phi. That is our second information that we have. And the third one that we have is this particular thing. Where is the y? Here it is. So this y equal to r sin theta sin phi. So we have got three equations, which I have shown it by highlighting them. These three equations are the required equations for the spherical polar system, and you got it. That's all. And now we are going to consolidate and then write down that the relation between the Cartesian system and the polar system is this. This is the relation. How do you know that this is the relation? Means you see here z represents Cartesian, theta is polar. Similarly, x represents Cartesian, theta is polar, phi is polar. So you have the relation between the polar means spherical polar. Remember, the if you don't use any word and simply if you say polar, it means two-dimensional polar. When we are moving to the three-dimensional polar, you have to clearly tell whether it is cylindrical polar or spherical polar. Okay, so now in the case of the spherical polar, you have the variables on the right hand side. On the left hand side, this is the left hand side, you have the Cartesian. Similarly, come here, this is the Cartesian on the left hand side, and the right hand side, everything is spherical polar. And therefore, these three equations represent the relation between Cartesian coordinate system and the spherical polar coordinate system, and that's all about it. And now we will write down simply and say that the set of equation we'll write down, then it would be easier to find more relations from that. So let me erase some portion and then write for I don't have space. Okay, I can write down here. So let me write down that z equal to r cos theta. Z equal to r cos theta is the first equation that we got. That is why I'm writing in the first place. So it will be convenient. Instead of writing x comma y comma z, we didn't get like that. First we got the z equal to r cos theta is our first equation that we got, and therefore let us write it in the very beginning. And afterwards we got either x or y. X or y we can write in any order. But since we have written already z is the first equation, we will then write y equal to r sin theta sin phi. Theta and phi is very carefully outright. You should not interchange theta phi, then the entire thing will be wrong. Then x equal to r sin theta cos phi. And that's all. Once you have this, let us give some numbers here. 1, 2, 3. So equation number 1 to 3 gives So this is the conclusion. I have written the conclusion that after doing this exercise, we have three equations, and these three equations give the relation to convert the point in the polar system or from, that is, let me explain once again. To convert a point, I didn't write from, but I have written to. So from is clear. From means you are starting with the spherical polar coordinate system. So that is the from. To means you are going to destination. That means you are going to reach the Cartesian system. So from to is important. You can't interchange them. So once again, let me explain. Equation 1, 2, 3 is to be used when you have a polar coordinates with you, and if you want to convert to Cartesian, you can use. But if you want to do the other way means start with the Cartesian system and reach the polar system. For that, you can't use equation 1, 2, 3. Okay, you have to rewrite them and then simplify. So that is why this 2 is important. Okay, starting from the spherical polar system and reaching the Cartesian system. And okay, let us see what happens if you are asking the reverse question. That is quite simple. But we have to work out a few steps. Okay, for that we will do now. So keeping this 1, 2, 3, let us now do some small calculation. So that we'll do now here. So consider what will happen. So if you are going to sum and square this, let us sum and square this. Then what will happen is x square plus y square. So these two things, then that will be equal to, on the right hand side, I will be getting r square sine square theta. And then sine square phi cos square phi. Now here these two things will become 1, and that's all. So if you are going to square the equations 2 and 3 and add, you will be getting this. So that's fine. And so that gives you, once again, let us simplify this. That gives you that square root of x square plus y square equal to r times sine theta. So let us consider that this is equation number 4. And anyway, equation number 1 is there. Okay. So now what we will do is, you try to manipulate further. Suppose if I am going to divide these two equations, let us say 4 and 1. So equation 4 divided by equation 1. If you divide that, you get r cos, this is r sin theta and that is r cos theta, and therefore you will be getting tan theta. So tan theta will be equal to this by this. Z. So that gives you theta equal to tan inverse of So this will be equation number 5. So equation number 5 is the one that is required for doing the reverse conversion. Okay, so let us complete this, then we will write down the conclusion. So equation number 5 we got like this. Similarly, we can do some more manipulation by squaring and adding all the 3. That means let us do that. So let us say that equation 1 square. Equation 1 you square it, and then equation number 4 also you can square and then add. Equation 1 square plus equation 2 square, of course that's the meaning. Equation 1 square plus 2 square plus 3 square. All the 3 equation you square and add, then what happens is we get like this: x square plus y square plus z square will give you r square. And that's all. So that gives you r is equal to square root of so that is your equation number 6. And we can still we have to do one more manipulation, because we have found out r. Actually, we can see this. We have found out r, we found out theta, but we did not find phi. So phi has to be determined. So for that, what to do? How to calculate phi, you see. So you have to calculate the phi if you consider equation number 2 and 3, because equation 1 doesn't contain 5, right? So that is not required. So take this 2 and 3 and let us divide 2 by 3. Equation 2 by equation 3. But remember what is the appearance, because we are now going little away from the board. So you have to remember what was there. Or I'll show a line here otherwise. So let me write down what is that we are doing. Equation number 2 divided by equation number 3. That's what we are doing. So that will give you y by x. Okay, so you see y by x will come, and these two things will cancel, and on the right hand side you will be getting tan phi. So you remember y by x equal to tan phi. So let me write down that. So that gives you y by x will be equal to tan phi. This is what you are going to get, and that gives you phi will be equal to tan inverse of y by x. So now this is equation number 6, means let us say that this is 7. So now we got the conclusion. The conclusion is equation number 6, equation number 5, equation number 7. So this is the order I am writing, because you see why I am writing 6, 5, 7 means 6 gives you r, and 5 gives you theta, and 7 gives you phi variable. So therefore they give r, theta, phi. So they can be used So this is the conclusion. You can use equation number 6, 5 and 7 can be used to convert from Cartesian coordinates to the spherical coordinates. So from and to is important. If you are inverting them, then the equation numbers are changing. Instead of 6, 5, 7, see, you have to use the previous one. You have to use this one. Equation 1, 2, 3 you have to use. So this is one conclusion, and the other one is the other conclusion. So we ultimately have now what is meant by a spherical polar system and how to convert a point. Now remember one thing, what are you converting is, you are converting a point. Point means x, y, z. Only point is converted. We have not done any differentiation. We didn't find what is the differential element. That we have not calculated. What is the differential volume? We have not done. So that we will do later. So right now we have only a methodology to convert only the point. Point means here it is there. So this is the point. The point P, x, y, z, that can be converted to equivalent value P of r, theta, phi. So this conversion only now we have seen how to do. Now what is to be done still is that, or what is to be understood further is that you have to identify where are the unit vectors. That is very important. And you'll have to also learn how to convert the unit vectors from the Cartesian to the spherical polar system. That is much more important and is also little bit difficult. Now conversion of the unit vectors is more important and more difficult. So that is yet to be done. So then afterwards we have to do the differential elements, surface element and volume element. Differential element means if the radius of the sphere increases a little bit, then we say that dr. If the angle changes little bit, then we say d theta. So those things are the differential elements, and we have to discuss on the differential elements. I think that part we will do in the next class.